Today we're going to cover Chapter 11, Section 7. Today we're going to cover surface area of cylinders and surface area and volume of cones. Now, technically in our textbook, 11.7 is just surface area and volume of cones. However, if you remember back from 11.5, that's where we were going to be covering surface area of cylinders, but I told you that wouldn't be on the test that you took yesterday. So we're going to now put it on the quiz. So let's go back over the surface area of a cylinder, which I had shown you back when we covered 11.5. And that formula to calculate surface area of a cylinder is going to be for the lateral area, and I showed you with my piece of paper how I unrolled it, that when you unroll it, it makes a rectangle. And that lateral area is 2 times pi times the radius times the height. And if you remember, when you unfolded that cylinder and it made the rectangle, this was up here, this length is like the circumference. And over here would have been the height. So this 2 pi r is this length up here, which is really the circumference when you roll it back up. And then we have it times the height. Then for total surface area, notice both bases are circles. So that's why it's 2 pi r squared. And then you had your lateral area, which is the 2 pi times radius times the height, where h in this formula is going to be the height of the cylinder. So this was the same example that we did back in 11.5 where we only calculated the volume. Now we're going to use the same figure and calculate the surface area. But we're going to do it step by step. So in this particular picture, the 5 is the radius and the 7 is the height of my cylinder. So in order to calculate the base, the capital B, remember your base is a circle, so we're going to be doing pi r squared. So left in terms of pi, this would be pi times 5 squared, or 25 pi. So if it says leave in terms of pi, this would have been your answer, and this would have been centimeters squared. But if it says using your calculator and using the pi button, rounded to the hundredths place, 78.54 centimeters squared. For the lateral area, you're just going to memorize it to be 2 times pi times radius times the height. So if I fill in those numbers, 2 times pi times 5 times 7, left in terms of pi, this is going to be 70 pi, because 2 times 5 is 10, times 7 is 70, and again, still centimeters squared. However, if it says to use your pi button and round to the hundredths place, this will be 219.91 centimeters squared. Now the abbreviation for surface area or total area, sometimes you'll see the letters TA for total area. Sometimes they'll refer to it as surface area. But again, that formula, 2 times the base area plus the lateral area. But what's nice about a cylinder, it's just a set formula because that base shape will never change. So it's 2 circles, so 2 pi r squared, plus the lateral area, 2 times pi times the radius times the height. So let's go ahead and fill it in. 2 times pi times 5 squared plus 2 times pi times 5 times 7. So we already did the base. Remember, it was 25 pi, but we got 2 of them. So this will actually become 50 pi. And then here, this is the same that we just calculated in part B. It's the 70 pi. And then if it says leave in terms of pi, 50 plus 70 is 120. And these would be centimeters squared still, rounded to the hundredths place, 120 times pi, 376.99 centimeters squared. I like to do whenever I'm doing these problems, instead of multiplying 50 times pi and then 70 times pi, what I like to do is just go ahead and leave it in terms of pi first. That way I don't have to keep writing all those long decimals in my work, because you can't round until the end. But it's up to you whether you wanted to multiply 50 times pi, write down that number, and then 70 times pi, write that number, and then go back and add them. It's totally up to you. So here's a picture of a cone. Up at the top, this is the vertex of the cone. Then our base shape is a circle. The height is going to be that perpendicular segment that goes from the vertex down to that circle base. We're going to use this height for volume, but we're going to use the slant height for the surface area. The slant height is going to be indicated with a lowercase letter L, like in italics. So we'll use this for surface area, or if they ask for total area. They both mean the same thing. So we use slant height for surface area, and we're going to use the height for volume. So for the surface area of a cone, the lateral area of the cone is represented by the formula pi times radius times the slant height. I know that looks like a 1, but it's a lowercase letter L. So this is the slant height. And then for the total surface area or surface area, it's the area of the base, which is pi r squared, plus the lateral area, which is that pi rl. So this is the base shape, it's a circle, and then this is going to be your lateral area, or like the sides of the cone. And again, the L there is the slant height. This shape that's down here at the bottom, this is actually a net of a cone. You probably saw nets back in middle school. So again, your base shape is this circle, and then this is the lateral area when it's unfolded. Okay, so here is the formula for volume of a cone. So if you remember, the cylinder was pi r squared height. Now, like the pyramid, we're going to multiply it by 1/3 or divide by 3. So another variation of this formula, if you'd rather do pi r squared height and then divide that answer by 3, you can also do that. So here's our first example. So the 5 in this picture, this is my radius. The 8 in the picture, this is my slant height. I need this slant height for surface area. Notice what we don't have is the height. So we need to find that height when we get to part D, because we need it for volume. Notice what was created here is a little right triangle. So in order to find the height, I'm going to be doing a squared plus b squared equals c squared. I'm going to use Pythagorean theorem to get my height. So my slant height is the hypotenuse. So I'm going to put 8 squared here. And then it doesn't matter if the 5 is the A or the B. So let me go ahead and just say it's going to be 8 squared plus 5 squared. And now I'm going to solve for h. So I'm going to be doing h squared plus 25 equals 64. Subtract 25 from both sides. And h squared is equal to 39. I don't want h squared. I want h, so I got to square root it. So h is equal to the square root of 39. If I could break it down, I would. Now, I'm just going to leave it like that. I'm not going to turn it into a decimal yet. it'll make it easier when I plug it into the formula. Now I have everything I need to answer the questions for A, B, C, and D. So remember, your base shape is a circle. So we're going to do pi r squared here. And remember, your radius is 5. So we're going to do pi times 5 squared, which gives me 25 pi. And these were meters, so this will be meters squared. This would be left in terms of pi. But if it says to round to the hundreds place, this would be 78.54 meters squared. The formula for lateral area of a cone is pi times radius times slant height. So let's fill them in. Pi, the radius is 5, the slant height is 8. I'm going to multiply 5 times 8, and I get 40 pi. And these are still meters squared. Rounded to the hundreds place, 125.66 meters squared. For surface area, and again, you could also sometimes see it called total area. Remember, area of the base plus the lateral area. So base shape is a circle, pi r squared, lateral, pi rl. We already did the base. It was 25 pi. We already did the lateral area. It was 40 pi. I'll add those together. Left in terms of pi, 65 pi, and again, meters squared. However, if it says round to the hundreds place, 204.20 meters squared. So just read how it wants you to leave the answer. And then the last part, since we already calculated our height, now we can just plug it into the volume formula. And the formula for volume, 1/3 BH, or remember you could do BH divided by 3. So 1/3, and my base is a circle, so pi r squared times height. So 1/3 pi times 5 squared times the height, which is the square root of 39. So once I multiply all of this, my volume, rounded to the hundreds place, 163.49 meters cubed. More than likely, I wouldn't ask you to leave this in simplest radical form or in terms of pi when your part of it is a radical. But if I did, what you could do here is just square the 25, multiply that by 1/3, put the pi symbol, and then put the radical. Really, the order of the radical and the pi wouldn't matter. But again, more than likely, when we've got a pi and a radical, I'm going to tell you to round it. Notice on this cone, they've given us a diameter. The 24 here is a diameter. So in order to do any of the formulas here, I need to turn this into a radius. So once I go ahead and divide that by 2, I can see my radius is going to be 12. And then the 13, again, is the slant height. It's the height going down the side. I need to find the height. So again, I'm going to do Pythagorean theorem. So I'm going to be doing h squared plus 12 squared equals 13 squared. This is actually a common Pythagorean triple. But again, if you haven't memorized your triples, let's go ahead and just do the Pythagorean theorem. 12 squared is 144. 13 squared is 169. Subtract the 144. And I get h squared equals 25. I don't want h squared. I got to square root it. So the height is equal to 5. Now that I have the value of the three variables that I need, I can plug it into the formulas. So for the base, again, it's a circle. So we're doing pi r squared. So my radius again is 12. So pi times 12 squared, 144 pi. And these would be meters squared. Rounded to the hundreds place, 452.39 meters squared. For the lateral area, remember that formula is pi times radius times the slant height. So my radius is 12, my slant height is 13. Once I multiply 12 and 13, I get 156 pi. These will still be meters squared. And multiplying 156 times pi, 490.09 meters squared. And that would be your lateral area. And now for surface area, or it's also called total area. Remember that formula is the area of the base, which is pi r squared, plus the lateral area, pi rl. So again, remember this is base plus lateral. So 144 pi plus the lateral, 156 pi, 300 pi, and again, these are still meters squared, rounded to the hundreds place, 942.48 meters squared. Let's try the volume. Remember that's 1/3 BH. And again, remember your B is a circle. So pi r squared times height. And let's fill it in. So 1/3 pi times 12 squared times the height, which I calculated, which is 5. So 1/3, 144 pi is the B, and then times 5. So once I multiply those three numbers, I get 240 pi. These would be meters cubed, but rounded to the hundreds place, 753.98 meters cubed. Now, in some of the questions in the homework, you may have to work backwards and maybe find a height or a radius. So not only will you just work straight forward with the formulas, also be able to work backwards. Okay, so for similar solids, remember, once we find the scale factor or the ratio of the corresponding linear unit, we're going to cube that and then put it into a proportion. So notice they gave us the radius of both cone A and cone B. Let's say they ask us to find the scale factor. Now, in the homework, they're probably not going to ask you for it, but if they did on a standardized test, to find the scale factor, we have to figure out what did they do to cone A to make it into cone B. So I would find the radius of cone B and put it over the radius of cone A. So B is 9, A is 3, 3 to 1. My K, or my scale factor, is 3. Now, if they just ask you to find the missing volume, you could put A over B. You don't have to do B over A. So then, when we're trying to find the volume though, so the volume of B over the volume of cone A, we take that scale factor and we need to cube it. So then we would be using 27. But what I like to do is put it into a proportion. So I'm going to take my radius of B over A. So 3 over 1, I'm going to cube that. And then I'm going to take the volume that I'm looking for, that'll be my variable. And then the volume of cone A will be 15 pi. So I'm going to go ahead and cube that 3 over 1, 27 over 1, and now I can cross multiply. So I'm going to multiply 1 times x, 27 times 15 pi. So 1 times x is just x. 27 times 15 pi left in terms of pi is 405 pi, and these are feet cubed. Now, if it says to round to the hundreds place, then we have to multiply 405 times pi, and we get 1,272.35 feet cubed. All right, and then the last example, it's a composite solid. So to find the volume of the composite solid, what we're going to do is find the volume of the cylinder and add it to the volume of that cone top. Yeah. Okay, so this is the cylinder. And then we're going to find the volume of the cone, which is in the top. So let's go ahead and write down the formula for volume of a cone and a cylinder. So for the cylinder, remember it's pi r squared times height. So it's the area of the base times how tall it is. And then this one is going to be 1/3 pi r squared height. So it's the same formula, we're just multiplying it by 1/3 or divide by 3. So let's fill in. Now the R for both of these is going to be 3. However, there's 2 different heights here. So the height of the cylinder is here, and then the height of the cone is up here. So if you want to add little subscripts and say this is going to be height number 2, and this will be height number 1, you don't necessarily have to do that. Just know that the cylinder has a different height than the cone. So if I fill this in, pi times 3 squared times its height, which is 10. And then over here, do 1/3 pi times 3 squared, and its height is 5. So I'm going to first do it and leave it in terms of pi. So if I do pi times 9 times 10, this gives me 90 pi. Then for the blue, 1/3 times pi times 9 times 5. This will give me 1/3 and 9 is 3 times 5, 15 pi. Now, left in terms of pi, 105 pi centimeters cubed. However, using your calculator and rounding to the hundreds place, 329.87 centimeters cubed will be the final volume of that composite solid.